lasers. We recently posted a video called The Poor Man's Clean Room, where I showed you some of the equipment and the techniques that you can use to maintain and clean high-end optics, including high-energy laser optics. I also showed you how for just a couple of dollars in a few minutes' time, you can construct a temporary clean room for assembling these components. The reason we did that video is at the beginning, I showed glimpses of a laser project that I was currently working on. The fact is, I was working on two. The one that you saw in the video is pretty exciting. It's a new approach to producing high-powered tunable laser light. But the fact is, the second laser is actually more powerful, and it's more conventional in its design. It's right here. This little laser weighs 1 kilogram and produces over 500 watts of visible laser light. It is a beast. Eat your heart out, Styropyro. This thing has been a lot of fun to play around with, but that age-old question came up. So, what are you going to do with it? Well, we've been following the conflict in the Mideast and reading about some of the different weapons systems being used, specifically Iron Dome. Now, many of you have probably heard of it, but for those who haven't, it is a portable or mobile, multiple rocket defensive battery that takes down airborne threats in a hemispherical region around the installation, hence the name Dome. It's been around for about a decade, and the Israelis are very proud of it because it is very effective. However, during this conflict, a couple of weaknesses in the system have become more apparent, and these are weaknesses that are typical of many weapons systems. Most wars are won economically. If you have an $8 million tank and you can disable it with an $80,000 rocket, one side is more likely to win, and it's probably the side utilizing the rockets. It's very difficult to win a conflict when there is that kind of asymmetry in terms of the expense. Each of the rockets in the Iron Dome system costs about $100,000. Now, if it's taking down a multi-million-dollar drone or an aircraft, it makes economic sense. But not all of the threats fit those categories. For example, you can have a smaller drone, maybe not like this Mavic here, but even DJI manufactures larger drones, for example, the Matrice. This drone can carry kilograms of cargo to a particular location. In addition, there are radio-controlled aircraft. These things fly at low altitude, they're very maneuverable, and if outfitted with a turbojet engine, they can be remarkably fast. And these things are becoming progressively less and less expensive with time. And then, of course, there are rockets. In previous videos, we showed you how easy it is to build high-powered rocket engines. Something like this can be constructed by somebody with not a lot of expertise, very few tools, for a couple of $100s. And that brings up the second problem. You can build a lot of these. Even a very sophisticated defense system can be overwhelmed by a less sophisticated attack through the sheer weight of numbers. Even if your economy would support the construction of a huge number of defensive rockets, you have the logistics of building them, storing them, transporting them, and reloading the batteries more quickly than the attacks are coming in. It's a problem. Hence, the development of Iron Beam. This is a mobile defensive laser system that was originally developed by the Israeli defense company Rafael. A few years later, they decided to collaborate with Raytheon to upgrade and to deploy the system. This system is very effective at destroying very small targets, but is not in any way a replacement for Iron Dome, simply because even the most powerful laser system is a mosquito bite compared to the amount of energy that can be delivered by even a small rocket. But moving at the speed of light, targeting and tracking in milliseconds with an almost limitless reload capability and costing about $1 a shot. This flips the asymmetry in terms of quantity and cost back in the area of the defense. Used in conjunction with Iron Dome, they're synergistic. They each plug the weaknesses in the other system. And the technology for building something like this is not difficult. It's actually easy. Sorry, Raytheon. As we covered in our previous video on satellite-based lasers, you can almost off the shelf purchase with a check, a large check, fiber lasers that generate over 100,000 watts of continuous output from companies like Enlight, Raycus, Trumpf, TRUMPF Corporation, and IPG Photonics. These are complete laser systems that are ruggedized and built for 24/7 operation in an industrial environment. Even the largest of them weighs about 1.5 tons. This could easily be carried on the back of a mid-sized truck. The power requirements are not daunting. The power of the batteries and the gasoline or diesel regeneration system could fit in the footprint of a large portable arc welder, like those made by Miller Electric. The fibers, the optics are available worldwide for laser machining and cutting operations. The stabilizing galvanometers that stabilize the beam internally are available from companies like Canon. And the large mobile gimbals that move the laser head to track the targets are available from companies like Aerotech. The hardest part of the project is not actually the laser. It's the target acquisition, the tracking, the prioritization. It's the software. Now, there was a great movie years ago, E.T., where the little creature is stranded on Earth and needs to contact its relatives to rescue it. And it constructs a little transmitter from an old phonographic record player, some electronics from some toys, a pie tin, some aluminum foil. It's a cute scene, but it actually suggests something very profound. We are surrounded by technology that has broad capabilities if we only recognize it. This is the DJI Ronin or RS3 Pro photographic camera gimbal. We use this for our videos. It's made out of carbon fiber. It has a load capacity of 4.5 kilograms. Our laser, camera, and lens combined weigh about 3 to 3.3 kilograms, well within the budget. And when attached to the RavenEye transmitter system, this camera can transmit its image to a phone or to a computer. And using the embedded AI inside the RavenEye, it can do facial recognition, body, and object tracking. So, to start the demonstration, what we're going to do is show you just how powerful this laser actually is. All right. Everybody got their goggles on?
Yes, sir.
All right. So, Goldfinger, you expect me to talk? No, Mr. Bond. I expect you to die.
No. There's some flame there.
Yeah, I think I better turn this off. But it's so good. Fire in the hole. Whew. Wow.
Can you bring that closer?
Yeah.
Actually, bring it to this camera.
Now, just to keep in mind, because of the power of this laser, one of the things that we did is we put a couple of layers of flame retardant expendable gypsum board or drywall behind the target, because this laser can actually cut through steel and we didn't want to damage the inside of our warehouse. In addition, each one of the cameras that are imaging the target and me have a special filter in front of them called a notch filter. It lets pretty much the full spectrum of light through, but has a little dip or a little notch located at the same wavelength as the laser, so that these cameras only get 1 part in 10,000 of the light coming from the laser beam, because being focused right at the spot, they would instantly damage the light-sensitive chips. The one camera that we put off to the side and strategically prevented it from being able to see the focal spot allowed you to see how bright this really is by just imaging the scattered light in the room. And to put that in perspective, realize this is not a darkened laboratory. This is not a rave or a laser light show. This is a fully illuminated warehouse with 1,600 watts of high bay metal halide lighting. It's bright in here, and still the beam is as visible as it is. This thing is a beast. Now the fact is though, a target isn't going to sit still. Okay, you can see that I've mounted the target now on a little gimbal motorized system that allows me to rotate it. I'll show you what I'm talking about. So we're going to lock on this target, and then we're going to fire it. Okay. So if you hand me the gimbal.
There you go.
Right. And now you will do the adjustment. Now the camera is sending the image through the Raven Eye down to the phone, and using the joystick on the back of the gimbal, you can center the image in the center of the field of view. And there's a little crosshair on the phone so that you can see where that is. And when you're happy with that position,
which is very difficult to get perfect, especially with this range that we're dealing with. Ooh, that's pretty good.
okay. Then drawing your finger across the image, you can create a little box, and that designates the target. If you're unhappy with the box, you can redo it any size you want. Sometimes a larger box will be less likely to lose the target, but also a little less accurate on the positioning of the target.
Right, and you might want to do it a bunch of times and decide like what you think is best. That might be a little bit too big.
That looks pretty good.
Okay.
Okay.
Yeah, I think that's nice.
All right, so you want to take the gimbal?
Yes, we'll do.
All right. You've got your goggles on.
Yes, I do.
I do too. All right, so I'm going to go ahead and I'm going to arm the system and then turn on the motor. And then I can see on the phone that it's in fact continuing to target it.
Got some smoke.
Yeah. It's pretty nasty here. Yeah, it worked. Now, you can see that it's not perfectly centered in the middle of the target because we designated the entire target as the field. And clearly, this gimbal is not optimized for this type of application. But it's actually intentional. They intentionally added a couple of features to the software to create a more organic tracking, trying to imitate the performance of a human videographer. The two features are called deadpan and smooth tracking. Deadpan stands for something like dead period before panning. And what that means is that if you have a human videographer and they're looking at a subject and the subject moves, the videographer moves the camera. They move the camera. There's a little bit of a delay in the panning simply because of the human thought process. The other property called smooth tracking is something like damping. What it does is that if you have the videographer walking along and they are filming a subject that might be moving a little bit while they're talking, rather than lock on the subject like a target and then having the field or the background sort of moving and shaking in the background, what the camera software does is it gives a little bit of wobble, a little bit of reduced responsiveness, so that, like a human being, they don't accurately follow the target, but they tolerate a little bit of shake, a little bit of movement, so that you don't make the viewer nauseated. But these two factors are arbitrarily added to the camera. Or I should say they're added for a different type of purpose. Clearly, if you had access to the software, or you could hack the software, what you could do is eliminate those, and then the gimbal will target directly onto the subject, the center of the subject, and it won't drift. This is something that obviously would be useful to do if you were going to be using this for this application. Nevertheless, let's see what happens if we try a target that's a little bit less predictable and random in its motion and see if we can still hit it. Okay, what we did is we mounted a balloon on an RC truck, and we're going to be driving it back and forth randomly in front of the backdrop, and we're going to target it. Right now we've already located it on the Raven Eye, and we have the target designation, so we're ready to go. Got your goggles?
Yes.
Okay.
And I have the controller here.
All right, so I'm going to arm the system and go ahead and start driving.
And so you can see it's moving back and forth, it's tracking it. And I'll stop it. How about now, I guess?
I'm going to do a little more driving.
Do a little bit back and forth. Still got it. Even with the pallets in the background, it's
Yeah.
still got it.
I love this stuff. I could do this all day. Now, something to keep in mind after disarming this is that you don't have to mount the laser on the gimbal. If, for example, you had a fiber-based laser, you could simply run a very small pigtail from the laser generator up to a collimating lens that allows you to focus and aim the beam. This would be substantially lighter than the existing laser and allow you to transmit tens of kilowatts downrange. The other thing you'll notice is that I've been firing this thing manually. This is not actually the switch that feeds the approximately 1,000 watts into the laser. This is a low voltage trigger, 5 volts, that sends a signal to an SCR, or silicon controlled rectifier. It is a very high speed, high voltage, high current switch which does the actual closing of the circuit. Because of that, it would theoretically be possible to drive this laser by firing it from a computer. A simple program on the computer would allow it to identify the little green box, and when it's centered over a few designated pixels, it could automatically trigger the laser in microseconds. The laser is solid state, so there's no warm-up, and the switch operates in microseconds. It could fire inhumanly fast. The reason we didn't do that is simply because turning over all the control of a powerful laser like this to the computers is a bit of a safety issue. If there was a ghost in the machine, there's always the possibility that this thing could take off and decide to attack its creators. So we've kept the human interface just for safety. The fact is, we do not advocate the use of weapons like this. We're not proponents of these types of weapon systems. The reason we did this video is to demonstrate just how easy this is to do. Because of that, we're going to see weapons like this springing up all over the world. We're going to see them in combat. If you're skeptical, Take a look at the US-based laser company Nuburu, N-U-B-U-R-U, and Google search who they recently added to their board of directors. Now, in the 1990s, the UN passed a resolution signed by over 100 nations indicating that they would not use lasers against human targets. But
The code is more what you'd call guidelines than actual rules.
so, keep your head on a swivel and stay safe. Now, in our next video, we're going to show you something else that you can do with high-powered lasers like this, and it's a lot of fun. In addition, I'm going to take this laser apart and show you how easy it is to construct it if you want to build one yourself. And if you like the kind of stuff that we're doing on this channel, please take a couple of seconds and subscribe. We're getting tantalizingly close to 1 million subscribers, and that pushes the YouTube algorithm to distribute our videos to a much broader audience. And if you have been following us for some time and think that you're subscribed, take a couple of seconds and confirm that. We've had a lot of complaints from viewers that have been unsubscribed without their knowledge. I'm going to give YouTube the benefit of the doubt and assume that it's just sort of an undesirable side effect of their routine subscriber housekeeping algorithms. But if you'd check, I'd really appreciate it. In any case, thanks a lot for watching the video. Stay safe, have fun, and I'll see you soon.
Okay, and that's still tracking, so that's fine. And hopefully it doesn't go ape shit once it pops, like if it's trying to find something that I don't need, like this kid.